Hey there, Calc kids. Welcome to 5.3 integrals and antiderivatives and such. Okay. I'm just going to put this away for a second. Holy smokes, first things first, let's talk about some rules for integration. Okay, there's some things that pop up. They're going to come up a lot. Take your time. You're going to have to write all these. You have your order, 0. Order just says if you switch your lower and upper term, upper and lower term, just make it negative. Okay, you guys want to see an example of that? Yeah, everyone wants to see an example of that? Well, okay, then I'll do an example. Woohoo. Okay, I don't know what's going on my computer here. I think it's time to get a new one. So for example, if I knew my integral from 2 to 4 of f of x is 3, then my integral from 4 to 2 of f of x is negative 3, right? Your zero property that says from a to a, your integral is 0, which makes sense because of your area. Well, you aren't going anywhere on the interval. That's a point, and a point does not have area. Doesn't matter what the function is. Okay? Constant multiple, same as derivatives, says that if I have some k from my function, I can pull it out. Okay, that will come in handy. Okay, same with negative signs. If you have a negative, just pull it out. Okay. Sum and difference is the same as your sum and difference was for derivatives, which is if you're adding two functions together, you can integrate them separately and then add them together, and it'll still work. Who'd have thunk it? Sorry guys, don't know what happened there, but I paused it. Oops. See, I'm just a hot mess. Additivity is a very neat rule. It says if you take the area from A to B and add it to your area from B to C, you get the area from A to C. If you aren't taking notes, hit the rewind button. Go back and take notes on this. What that says, if I know the area from 1 to 2 of f of x is 3, and I know the area from 2 to 4 of f of x is 9, then my area from 1 to 4 of f of x, well, is 3 plus 9, which is 12, which makes sense because if you have some graph, right, and you know the area from 1 to 2, and then you know the area from 2 to 4, to find 1 to 4, you just add them both up. Not too bad. Not too bad. Max Min Inequality. That says if the max of f and the min of f are maximum min values on a to b, then your integration from your min of s times b minus a is going to be less than your integration, which is less than your max. If you didn't write that one, I would not have hurt feelings. Time to dominate. Domination. Okay. What this says is if a function is greater than another function from a to b, then the integration of it has to be greater than the g of x. So if f dominates g as a regular function, its integration is going to dominate it as well. Okay. And what it also means is if your function is greater than 0, your integral has to be greater than 0. Okay. Okay. Yeah. What am I? Let's do some examples for fun. So we know our integration from f of x. We know what for f of x from 1 to 4, negative 1 to 1, negative 1 to 1 on h of x, right? Right. Sorry, it's really snowing outside. This is winter storm minus. You guys haven't figured that out. Anyway, so we gotta find from 4 to 1. We gotta find from negative 1 to 4. And we gotta find from negative 2 to 2. So let's go. So from 4 to 1 f of x, ooh, that's fancy, right? It's negative 2. Then if I switch those around, it's going to be positive 2. You just flip your sign. Yay. Now, if I want to find the integration from -1 to 4, what do I do with these two areas? Well, this one goes from -1 to 1, and this one goes from 1 to 4, right? So all I have to do is add those up, and you get 3 as your area. Woohoo! And now the last beast. There's a trash can there. The last one says, find it from -2 to 2. Well, since none of those integration symbols have any 2's involved, you can't take the integration of that one because you don't know what the function is. You have not enough info. No info. Okay, I gotta check time. Let's have a 5-hour long video. Woo! Quick things that you guys need to know going forward is how to find the antiderivative. Okay, the antiderivative is opposite of taking the derivative. So you have to think whose derivative equals this function. Antiderivative, you go back to it. This way to do is do some examples. If I'm looking at x squared, my antiderivative. Now when you take a derivative, you subtract from the exponent and you bring out in front. So your antiderivative is you add to the exponent and then divide by your new exponent. Bam! And to check it, your derivative of x to the third over 3 is, bring the 3 out front, comes x, 3 minus 1 is 2. Works! Wunderbar! Okay, so basic rules, if you have x to n, your antiderivative, your integral, is x to n plus 1 over n plus 1. Okay, so if I have like 4x to the 5th, that's going to become 4x to the 6th all over 6, which would be 2/3 x to the 6th, right? Those are just some quick examples, okay? Hopefully they'll help you out. Man, he's crazy outside. Write it. Average mean value theorem says that if you're looking for the average value of a function from a to b, all you do is do 1 over b minus a times the integration of a to b of f of x. I don't know if I'm going to keep this in. Okay. Which makes sense because it's your total divided by how many pieces you went. Let's try one. Let's find the average value of this function from these numbers. So I set my 1 over 4 minus 0, because that's my a, that's my b, times my integral from 0 to 4, 2 minus x squared dx. Hooray! I feel like I skipped a lot. I might have to make a bonus video someday. Ooh. So this becomes 1 over 4 times, when you integrate this beast with our newfound knowledge, you get 2x minus x to the third over 3. Right? You're going to evaluate that from 0 to 4. Oh, Jiminy Crickets, we skipped a lot. Oh well, let's just keep going. What this says is you plug in the 4, and you subtract that from when you plug in the 0. Okay? So you get 1/4, 8 minus 16/3. Right? So you get 1/4 times, let's see, 16/3 is 5 1/3. Right? Because 8, that's 24/3. No calculator. Who needs a calculator? That's 8/3. So you get 8 over 24, which is also known as 1/3. Hooray! That's our average value. I'm gonna have to teach you guys something before you guys watch this video. Remind me to do that. But you can't. It's done. And here's proof that that's how it works. Okay? Here's your theorem. Right? Oh no, that's not proof. This is proof of something else. This says that if f is continuous from a to b, and at some point c, it equals your average value. Just like we did for derivatives, right? Just like we said, at some point it equal your instantaneous velocity. Okay, so it works here too. Who would have thunk it? And here's a picture showing that happening. You have some function from a to b. Your average value is right here. Right, your average value is this rectangle. And you have some point on your function that equals your average value. That's it. Don't be afraid to ask questions, and have a lovely day.